Good morning, all of you. So, as we know that last class we have been studied what is the physical properties of metals and as well as non-metals and as well as exemptions in physical properties, etc. So now let us comes to here in our today's class. We are going to start. The next concept is chemical properties of metals. So if you see, as we know, like how the physical properties of metals and non-metals are different. So the chemical properties also different, means metals and non-metals show different chemical properties. So first we will discuss chemical properties of metals and then after that we will discuss the non-metals. Now let us see what is the important chemical properties of metals. First one, if you will take the first important characteristic chemical properties of metals is reaction of metals with oxygen. What is this, guys?
Reaction of metal with oxygen.
Metals with oxygen. So oxygen in the sense of oxygen is available in where, Radina? Kevin, oxygen is available in where? Oxygen is available in air. That is so
atmosphere.
Reacting with the oxygen means in the sense of air. So general equation. So what is the general or basic equation? If any metal, not only particular metal. So first we should know standard equation of this point. Later only we'll go with the example. So let us start with the first one. So let me take any kind of example. Please respond me and tell me. So let me take any kind of metal. METL, metal plus reacting with what, guys? Oxygen. What is that? Oxygen. Oxygen from where? From air. They will form what, guys? Anybody can tell me? What it will form? Metal plus
Metal oxides.
Metal oxide. Metal oxide.
That's all. Metal oxide they will form. So the nature of this metal oxide is basic. So that basic oxide we should call as. What we should call? Basic oxide. They will turn. Basic means which litmus to which litmus, ra? Red litmus to red litmus to blue color. Very, very important. This is the standard equation of reaction of metals with the oxygen. Please all of you make a box for this. Very, very important. These equations, if you know, exam, you people will never commit any mistake because it will give us the idea. You understand? Everybody? So that is the first property of metals. Karthikeyan, reaction of metals with oxygen. They will form metal oxides. Understand? So if you take here, metal oxides are basic in nature. So some metal oxides, remember. So metal oxides are what is nature? They are basic oxide. That is why metal oxides also we can call it as basic oxides. And this will convert which litmus to which litmus? Respond me. Red litmus
to blue litmus.
Understand? Now, some metal oxides, some, not all, some metal oxides react with water. What will happen, guys? React with the water. So as we know that if oxides are reacting with what we should call, guys? Bases are dissolved in water. What we should have? We have some special name. What is called as? Anybody?
Formation of bonds.
They will form alkali. That is what I want the response from you all. Alkali. So you observe very carefully as we have already studied. So they are being basic in nature. They will convert which litmus to which litmus, ra? They will convert red litmus to
blue.
Red litmus solution to blue color. So if you take here, the vigorous of reaction with oxygen depends on the chemical reactivity of metal. Means vigorously. What do you mean by vigorous? Anybody? Means very fast, very effective, very danger. Understand? Like a fastest rate. How fast it is reacting with oxygen. How slow it is reacting with oxygen. It is depends on one thing. What is that? Chemical reactivity of metal. Means some metals will react directly with oxygen just if we'll expose to the atmosphere. Some we have to heat, then only they will react and they will respond. And some Even though you will heat also, then also they will never respond. Even strong heating, very strong heating only, they will react with oxygen. So that is why all of you should remember the vigorously, the rate of reaction, vigorous in the sense of very dangerous, very fastly. So the vigorous of reaction with oxygen is depends on what, guys? It depends on what? Chemical reactivity. That is what metal activity, man. Have you remember? So that is what you have to remember. So vigorous of reaction with oxygen depends on what, guys? Please respond me. Depends on the chemical reactivity. Chemical reactivity of metal. So what do you mean by chemical reactivity? Anybody in the group, please respond me. This many fellows are there. What is happening? Kevin, Nitish, Prasini. What do you mean by chemical reactivity? Means how fast it will react or how slow it will react. For example, if you take, why sir, what do you mean by this chemical reactivity? Some element, some metals, understanding, react with oxygen even at room temperature also. For example, anybody can say two metals we have. Just if you'll expose to the atmosphere also, they will catch fire. What is that?
Sodium and potassium.
Sodium and potassium.
Understand? So some metals, understanding, reaction with oxygen at room temperature itself. So examples we know that. Understand? Next, some metals reaction with oxygen, understanding, at the rate of heating. So if you provide heating only, they will. Example, first chemistry class and the chemistry, first example we will study. What is that? Have you remembered anybody? Pranav? Magnesium ribbon.
Magnesium ribbon.
Yes, that is. Who is this AVS Rahul? Rename. If not, I will remove. Okay. Can you able to see that? Some metals react with oxygen at room temperature itself, and some metals react with oxygen. We have to heat it. Is it this, guys? Yes or no? Next, some react on very strong heating, understanding, with oxygen at the rate of strong heating. Then only they will react with oxygen and they will form, understanding, metal oxides. Now, let us go with the examples. What is that, guys? Example. So now first example, as we know, what is the first example you guys are expecting first? Can you able to say?
Sodium.
Yeah, sodium. So let us take, you should tell me, I will say only word equation. So sodium reacting with oxygen. What is the state of sodium? Anybody? Speak loudly. Don't be hesitate to speak. What is the state of sodium? Sodium state is solid.
Solid.
Reacting with oxygen. Gas
Gas.
is equals to what it will form? Sodium oxide. Sodium is +1. Oxygen is -2. So now you tell me the formula. What will come? That is what I want. Na2O. That is. So Na2O. Now balancing. It is not balancing. So again it will form metal oxide. It is also in solid state. So what is balancing equation? Speak loudly.
2Na.
2Na plus O2 gives
2Na plus O2.
2Na2.
2NaO2. Understanding? 2NaO2. Then it will become not 2 here. Wrong. It is
4Na, sir. 4Na plus O2 gives 2NaO2.
That is what I am expecting. So perfectly, it is 4Na plus, again what? Oxygen. Oxygen become 4 only.
Oxygen 2 only, sir.
2 only. Very
No
good.
need to change oxygen, sir.
Yes. So 4Na plus O2 will give you 2NaO. Please, within 2 minutes, call the absentees, your friends. If they join or not, let them see. If not, I will log the meeting because some outside fellows are joining. Please make it. Your friends, call them. So many. Jessie is not there. Pranita, are you there? Inform them. Pranita is also not there. What happened? She wake up, correct? I don't know what is this. Tarani, are you understand Tarani? So what is the first reaction? Sodium reacting with oxygen, it will form sodium oxide. Valence is also I am saying once again. Why means you have to understand and you should not do the mistake again and again. Everybody. Padmavarshini, are you there in meeting? Okay. So now next one. So observe second example under the same thing. Under the same thing you take it. Under the same thing, if you take potassium. So you tell me potassium reacting with oxygen. What is the state of potassium? What is the state of potassium? Solid. Reacting with
Solid.
oxygen, gas. Under the same thing, it will form what? Potassium oxide, K2O, because potassium is +1, oxygen is 2 minus. What it will come, guys? Speak loudly. K2.
K2O.
Potassium oxide. So
K2O.
balancing again here what?
4K plus O2 will give
4K
2K2O.
plus O2 gives
O2 will give you
4K plus O2 gives 2K2O.
4K2 or 2K2?
2K2O, sir.
2K2.
Sir, 2K2.
Yeah, yeah.
Sir, 8 Ks.
Yeah. Atomic number, array atomic number not raw valence in array. It requires 2 more electrons. Karthikeyan. It minus means needs 2 electrons. Plus means donating 1 electron. Understand Karthikeyan? Atomicity is array. Now you are asking, forgetting everything. Not all study. So if we take here, potassium metal also reacts with oxygen. It will form what, guys? At room temperature itself. At room temperature itself. So they will form what? They will form. What will form? Potassium oxide.
Potassium oxide.
What is the nature of this one? Acidic oxide or basic oxide? This is the basic oxide. Understand?
Basic
oxide. So you remember potassium and sodium metals are so understanding highly reactive metals. Correct or not, Humaira? Harini? They are very highly reactive metals. So
Yes, sir.
very vigorously with the air. So they will catch the fire and start burning when they open in the air. Do you understand, guys? Just they will understand vigorously. They will react with very high energy will release when potassium and sodium react with the oxygen, because they will catch the fire at room temperature itself and they will start burning when they kept in the air itself. That is the reason always this sodium and potassium we have to store under what, guys? We have to store under kerosene. Understand?
Kerosene oil.
Oil. Because what, Nitish? Respond me, Nitish. I
They will
don't
react to the moisture, sir.
not. They will react with understanding to prevent the reaction with oxygen, moisture, and even they will react with the carbon dioxide air also. Carbon dioxide of air. This is the new thing. Nobody knows. So why we should store in the kerosene oil? Because they will react with understanding, guys. These two things, they will react with what? React with the oxygen, moisture, water, and as well as carbon dioxide. So that is why to protect us from this, understand, we have to store it in a kerosene oil. So you can observe here, since the sodium and potassium metals react even with at room temperature, so there we can say sodium and potassium, they are just reacting at room temperature itself. So we can say they are highly reactive metals or low reactive metals. They are
High
Reactive metal.
Reactive metal.
sodium and potassium we used to call it as very reactive metals. What we should call? Very reactive metals. That is you have to understand. Understanding, Amma? Please respond me. Tarane, Harini,
Yes, sir.
Kevin.
Yes, sir.
Yes, sir.
Yalni, Dilipan is not there. You check it. Akshay is not there. Humaira is there. Jesse is not there. Pranita is not there. Bhumika is not there. Ashika is also not there. Akil Arfan. These many fellows are. Akil Arfan is there. Akil Arfan is there. Okay. Please inform them. So sodium and potassium are very reactive metals. Why we used to call them as very reactive metals? Because they will react at room temperature itself. At room temperature itself, they will react vigorously with the oxygen and they will catch us fire. That is why they are called as very reactive. So if we'll take another metal is there. Actually, metal activity series will start with where, guys? This is nobody knows. I am saying you. Metal activity series starts from where? We will start the metal activity series with the
Potassium.
Correct or not? Please never call me a zebra. Yes or no? Potassium. Next one is what? Sodium.
Sodium.
Please never
Sodium.
call me
Calcium.
calcium, magnesium,
Calcium.
aluminium,
Magnesium,
that etc.
aluminium.
etc. will go. But before this, one more metal is there. Do you know that? Which is even highly reactive than this, which is very reactive. That is what we should call as lithium. Do you understand, guys? But metal activity series, it will start with the potassium. But another metal which is highly reactive, is lithium. It is just like sodium and potassium. Understanding? So it is also stored under what, guys? Lithium.
Kerosene.
Guys, lithium also. Understanding? Like water, like sodium and potassium. Actually, some highly PhD like that books, it will metal activity series will start with what? Lithium. Understand, Ra? But your textbook class 10th will start with the potassium only. So that is why we'll start with the potassium only. Okay, guys. But lithium is also same like. Understand, Ra? Nobody is responding. Same like what? Potassium and sodium. Like that is the reason we have to store like sodium and potassium. We have to store under water, store under kerosene oil. Kerosene oil, because it is also vigorously react with what? React with the
Moisture, carbon dioxide,
so
oxygen.
all remember this all the things. So lithium, sodium and potassium, these all the three things are called as, understand, alkali metals. What we should call? Alkali
Metals.
Understand, that belongs to the first group in the periodic table. So periodic table we will study in the 5th chapter. By the time you understand. So you should remember this lithium, sodium, potassium, they are called as what, guys? Alkali metals. What
Alkali metals.
Alkali metals. So they belongs to the understanding metals called as, they belongs to the first group of metals called as alkali metals. That is why they are called as alkali metals. Understand, guys? That is now. If you see here, most of the metal oxides. Are some noise is coming here? Who is that? Most of the metal oxides are insoluble in water. What is that, guys? Insoluble. That is why we cannot say all the alkalis are not basic oxides. All the alkalis are not bases, or all the bases are not alkalis, but all the alkalis are bases, because all the metal oxides not insoluble in water. Only few, but some of the metal oxides dissolve in water to form alkalis. For example, if you take sodium oxide and potassium oxide, they are the two metal oxides which are soluble in water. So, okay, so most of the metal oxides are insoluble in water. Only some will soluble, and they will form what, guys? Soluble in water, and they will form what? And they will form water. What they will form? They will form alkali. For example, if we'll take sodium oxide, what is the formula of sodium oxide? Anybody?
Na2O.
So sodium oxide, what is the state of that? Solid. Will react with water. What is the state of water? What is the state of water? It will form water. So you tell me, sodium and water, what is the come? It will form one of the most important base. What is that base? Anybody?
Sodium hydroxide.
Sodium hydroxide. Who said? Sodium hydroxide.
Sodium hydroxide.
So what is the formula of sodium hydroxide?
NaOH.
Understand? What is the state of it? Aqueous state. Understand? Balancing, tell me. Balancing. Here sodium 2, here 1 only. So what it will come? 2 NaOH. Is it now you check it. Sodiums are 2, oxygens are 2, and hydrogens also 2. That's all. So that is the first example of what, guys? Alkali. Please remember, this is called as alkali. Next, this is what we should call as basic oxide. What is that? Basic oxide.
Basic oxide.
Second example, tell me now. Second example. So you tell me now, alkali, basic oxide, which will convert which litmus to which litmus, guys? Red litmus to blue or blue to red? Which will turn
To blue.
which will turn red litmus to blue
blue.
litmus. That is, you should remember, red litmus to blue litmus. Because as we know, the sodium hydroxide is a water, base or acid? Base or acid?
Base, sir. Base.
You are in the class, everybody. I no need to ask you, everybody. You have to tell me. Next, same way, tell me potassium oxide. Potassium oxide. What is the state of this one? Which is in solid
Solid, sir.
state, water, which is in liquid state. So what will form, guys? What will form?
Potassium hydroxide.
Potassium hydroxide. KOH.
In
Aqueous
which is in
state.
what? Also balance. K2.
2 KOH.
Yeah.
2 KOH.
KOH.
Please write it. Please write it. Arun Karthikeyan. Very good. Everybody join. Almost right. This is also what, guys? Which will also convert into red litmus to blue. So it is also called as alkali. So remember, basically, most of the metal oxides are insoluble in water. So very few only soluble in water. So that is why we can say they are the what? Understand, Ra? So the example of a formation of alkalis, if we take sodium oxide and potassium oxide, because they are very, very highly reactive metals, as well as they will form base alkalis when they will react with the water. That is what. Any doubt, guys, still here? This is what the example one. Is it okay, guys? Please respond me.
Okay,
So
sir.
they will react at what temperature, Ra? They will react at room temperature itself. That is why they are called as highly reactive elements. Highly reactive elements. So if they will ask you in your MCQ, which metal is the highly reactive metal in the metal activity series? Which one? Potassium only.
Potassium.
All lithium is there, but lithium is not mentioned in our metal activity series. Understand, guys? Like sodium and potassium, lithium is also highly reactive, but lithium is not mentioned in our textbook. That is why. But they will ask you, along with the sodium and potassium, one another metal which is need to store under the corrosion. So by that time you have to remember, that is what, Adina, Arya? That is
Lithium.
So, second one. So this is the first example. Any doubt in this, you can ask me. So now let us go to the second example. That is, yeah, tell me, Karthikeyan. Ask me.
So these two metals only dissolved in water.
Yeah, they will form in basic oxide. Some other will be there, but these are highly reactive and they will form. That is why. Next, later we will see. Some more is there. I am not saying this only two. Very few will form. In that, these are the two examples which will form easily. Okay, Karthikeyan. Next, let me take magnesium metal. Everybody, what is the symbol of magnesium? Anybody? What is the symbol of magnesium? So magnesium metal. So as you know, magnesium metal does not react with the room temperature. What it is happening, guys? Does not react. You know, class 10th chemistry. This is the first reaction we have been studied. Yes or no? We have to heat. We have to heat the magnesium metal. So does not react at the rate of room temperature. So what we have to do, guys? We have to provide heating. Understand, Ra? On heating. Understand, Ra? Magnesium burns in air, which will give the dazzling flame. Do you remember which flame it will give you? Ra? Dazzling flame. White color flame. It will
White color dazzling flame, sir.
yeah, it will flame, and it will give you what? It will give you what?
Like magnesium oxide.
Yes, it will produce intense light. Understanding? Intense light and heat. That intense light only we used to call it as what, guys?
Dazzling light.
Dazzling flame. All of you should remember. And also it will produce what? It will produce the lot of amount of heat, and it will form finally one oxide. What is that oxide called, guys? Magnesium.
Magnesium oxide.
Magnesium is which state? Magnesium ribbon. Solid.
Solid state.
Oxygen, and it will form what, guys? It will form magnesium oxide, MgO. Magnesium oxide, which is also in solid state. Balance it now. Try to balance, all of you. What will come? 2mg plus O2.
2mg, 2mg,
2mg plus O2 gives 2mgo.
Anybody doubt means ask me. See, you should become an expert in balancing. Within a seconds, you have to balancing. Understand, Varsini? What happened, Elamati? Everybody. So that is. Nitish, you also say Nitish. So 2 mg plus O2 will give you 2 mg more. So here.
Sir, can go up, sir.
Okay. This is you have to read. You have to on heating. I will write here to make you more better understanding. You have to write this one. What is this? On heating. Okay, guys. And this one I will write. What I will write here? Anybody can say. This is what I will write. At room temperature. What it is? You can write here. At room temperature. At that of room temperature. TMP dot. It will indicate room temperature. Okay, guys. It will see, but easily you can understand. Highly reactive. Okay. So now magnesium you have to write what? On heating. So it will form what drop? It will form what?
Sir, intense light and another one what, sir?
Intense light and heat. Intense light and heat. Okay. Means dazzling flame and heat will produce. Correct or not? So now
Yes,
you
sir,
can
yes,
see
sir.
here. This magnesium oxide, it is partially dissolved, not completely raw. So magnesium oxide, partly dissolved, understanding, in water, and they will form magnesium hydroxide solution. What is that called as? Magnesium hydroxide solution. Remember that. Partially dissolve in water, so that it will form water, magnesium hydroxide, as we know that. So what is the formula? Magnesium hydroxide is a basic understanding.
MgOH twice.
Form what? React with the water, so it will form what?
MgOH twice.
MgO.
Magnesium hydroxide. Understand? So what is the formula here? Magnesium is 2 plus and hydroxide is -1. Anybody don't
Yes,
know?
sir.
Now anybody joined late or anybody don't know, you please learn this. So magnesium 1, oxide is a hydroxide is a water. Dina, polyatomic ion. What is it called? Polyatomic ion. So magnesium hydroxide. You may be asked me, sir, then why sodium is not coming, sir? What is sodium here? Sorry, potassium. Potassium is K plus 1. Hydroxide is K minus 1. So what will come? K1, OH1. So 1 means same thing. That is why KOH will come. Understand, Ra? Everybody. Doubt means you have to ask. Same way, what is the soluble here? NaOH. NaOH, tell me anybody. NaOH.
Sir, Na is +1, sir. OH is -1.
OH is -1. Others also it is good. So Na1. So we can say NaOH. Understand, Nitina, Karthikeyan, Harini? That is. So magnesium hydroxide. But remember, this is also will turn which litmus to which litmus star. It is also hydroxide. Metal hydroxide base.
Metal hydroxide, sir. Red litmus to blue.
Red litmus to blue, because it is also what? Magnesium hydroxide also a base. What is that? Base. That is why magnesium hydroxide we have a one importance. What is that, guys? We are using in where? Antacid. Why we are using antacid?
Milk of magnesia.
Milk of magnesia, sir.
Mixture with the water. It is called as milk of magnesia. Milk of magnesia, because we are using as an antacid. Yes or no? That is you have to remember. Okay, guys. This is what you have to remember. Any doubt in this? Please respond me. Yes.
No doubt, sir.
Yeah, but you have
No
to
doubt, sir.
You have to remember, it will only react partially, not completely dissolve in water. Understand, guys? It will only partly react with that. So, and what kind of light it will flame? A intense light with a white color, dazzling flame, and also it will produce a lot of amount of heat energy. Understand, guys? That is you have to remember it. So this is the second one. So litmus changes. What is the litmus changes, Ra? Arun Karthikeyan, litmus, red litmus to blue color it will change. That is what about the second one. Now, third metal, everybody, aluminium. What is the aluminium? Aluminium symbol?
Al, sir.
AL.
Yeah, aluminium.
Al.
So aluminium also won't react with normally. On heating only it will form. What is that? On heating only it will form. So observe very carefully. Aluminium. What is the valency of aluminium? All of you should remember.
3, sir. 3.
Aluminium 3 plus. Understand? So you should
3 plus.
Aluminium, what is the state of this? Varshini Bensi, Chimaira, solid state. Reacting with oxygen. Oxygen, what is the state? OG, gaseous state. Which will form, what is that? Anybody can say?
Al2O3. Al2O3.
Yeah.
Al2O3.
Yeah. Anybody having doubt?
Al2O3.
Al2O3. So that is what. So Al2O3. Now observe very carefully. Aluminiums are
Sir,
one.
this is in solid state or gaseous state?
Solid state, everything. Metal oxides are solid state only. Understand? That is Al2O3. So aluminium plus oxygen. Here, oxygens are here 2. So here 3. So we have to make it what? Balancing. 2 3s are 6, and here also 2 3s are 6. Now aluminiums are here. 2 2s are 4. Here how many will come? 4 should come. That's understand? 4Al plus 3O2 will give you what? 2Al2O3. Any doubt till here? Please respond me. Yalamati,
No doubt, sir.
Proud, sir.
Yalni, Dilip and why I should Tarani? Yo, now observe very carefully. Aluminium oxide, we have another behavior also. Observe this aluminium oxide. Actually, we can say, for example, you can take aluminium react with oxygen. It will see takes place less readily than magnesium. Compared to the magnesium, this reaction with oxygen is less only because it is also react with what, guys? On heating. What is that? On heating also. Compared to the magnesium, aluminium is less reactive or more reactive? Anybody?
Less reactive, sir.
Understand? Jesse, Bhumiga, and Pranita is not there. Call them. So now observe very carefully. So compared to magnesium, aluminium is what, guys? Aluminium is less reactive. Understanding, guys? That is you have to remember. So if you remember in metal activity series, so which is coming what? Potassium, sodium, calcium, magnesium. Then next what it is coming? Aluminium. So aluminium is less reactive or more reactive than magnesium? Less reactive,
sir.
That is you have to remember. But you can see, even though it is the metal oxide and they are basic in nature, yes or no? So observe very carefully. This is the note I am saying. Very, very important. Even though what is the aluminium oxide? It is a base or acid? It is a basic oxide or acidic oxide? Basic oxide. So remember, it is a basic oxide. Now, this basic oxide, something special is there. Some substances, they will react with the, understand, they will react with the bases as well as acids also. So some metals only, very rarely. So that metals is known as, that is called as amphoteric oxides. What we should call, guys? Amphoteric. Understanding? So now observe very carefully those metal oxides which will show basic as well as acidic behavior. Understand? They are called as amphoteric oxides. Will you be able to remember, guys? Some metal oxides are basic in nature and understanding, but some of the metal oxides show basic as well as acidic nature. Understand? Basically, metal oxides are what, guys? Basically, what is the metal oxides? Basically, metal oxides are basic in nature.
Alkali.
Basic in nature. What is that? Basic in nature. But few metal oxides will show both
Basic as well as acidic
nature, basic and acidic nature. So all of you should remember, very, very, very important, 1,000 times important, acidic nature. So whatever the understanding, metal oxides which will show both basic and as well as acidic nature, these are called as, remember, amphoteric oxides. What we should call ra? Amphoteric. AMPHOTERAC, amphoteric oxides. You people already know that. Class 8th itself I have taught you. At least have you remembered, one of you? Understand, Ra? Amphoteric oxides we can say. Understand, Akil Arfan? Very important element this is. So, basic oxide, which will show metal oxides, which will show both basic and acidic, means they will react with the base as well as acid. That is why they are called as special name amphoteric oxides. We have a very less number of amphoteric oxides. So, that is what you have to remember. So, I will say that names also. So, if you take for example, aluminium, zinc metals, they will form amphoteric oxides. What is the examples, guys? Aluminium, understanding? Also lead also. Aluminium, zinc and lead. Only three amphoteric oxides we have. Understand that names also I will say.
So why, sir, Na also reacts with HCl, that and all, no, sir? But they do not form basic nature, that is why, sir.
So, showing the acidic nature, that is what, understand, that is both nature it should show. That is what, aluminium oxide, zinc oxide, ZnO, because Zn plus 2 and oxygen 2 minus, so that Zn2O2 will come, so that Zn.
Sir, no, sir, I couldn't understand, sir. Why, sir, we cannot say Na and all?